Alright, good morning. This lesson is for my Trig-Precalc class. This is for 7.2. This is lesson number 2, but before I get started, I want to say I hope everyone is doing alright out there. Today's lesson, let me just jump right into it. It should be pretty simple for you guys. Again, this is a lesson that you saw in 9th grade, I believe probably in 10th grade. But it's a good review lesson. The last lesson I told you a story about Gauss and how, as a little kid, he realized he could add equations together. So we're gonna add equations together and make an x cancel or a y cancel. And in this lesson, we have to think a couple steps ahead. We have to find what would be an easier variable to cancel. We have to figure out what numbers we're going to multiply by, and if we set the problem up right, it should be a very simple problem to do. So let's jump right in. So the first goal is we're going to solve linear systems. Our only goal is we're going to solve linear systems by multiplying one or both equations. And I want to remind you that we already know how to multiply one or both equations. Back when we were solving equations that had fractions, our very first step that we would do is we would eliminate the fractions. And so if we multiplied everyone in the equation by 2, what we're going to see here is that we picked a number that makes the fraction cancel. Right, we would go about finish solving that. So you guys are well aware that we can multiply an equation by a number. So let's move on to our examples, and let me make sure I got everything fit into the frame, and I do. So this is our first example. Remember, our goal is to solve these by multiplying one or both equations, and this equation represents a line, this equation represents a line, and by making an x or y cancel, solving for the other variable, using that answer in either of the original equations and solving for the originally canceled variable, we find the point where the two lines cross. So in looking at this first problem, this is going to be the multiplying one equation, and let me show you what we're going to do. So I looked through this in the following way. Can I multiply 10 by a number so it turns into a 5? Technically you can, but you don't want to make numbers smaller. I mean, you can make numbers smaller, but it can create fractions. So there's not a nice whole number that I can multiply a 10 by that turns into a 5, but I can multiply 5 by a number so it turns into a 10. Now I have a negative here, so I want this to stay positive. So all I'm going to do is I'm going to multiply everyone here by the number 2, and I'm doing that because I know that I'm going to be able to turn this 5x into a 10x. So the original equation stays the same, minus 10x plus 4y is equal to 6, and now my second equation is going to become 10x plus 10y, and that's equal to 0. All right. Did I read that equation right? I did. I did not. This is supposed to be a minus 5. Sorry. In the assignments that I'm giving you, we're not going to get fractional answers, and so that's why I knew that this wasn't going to be right. All right, so let's now do what Gauss taught us we can do. We can add the equations together. You have 4, you owe 6, or you have 4, you owe 10. That means that you owe 6. So minus 6y is equal to 6. Divide out the minus 6. So y is equal to negative 1. All right. I like the bottom equation because the numbers are smaller, so I'm going to take this value of negative 1 and replace it into that y. So now I have 5x minus 5 times minus 1, and that's equal to 0. 5x equals, let's see, negative 5 times negative 1. 5x not equals 5x plus 5 equals 0. Subtract the 5, and we get 5x equals negative 5. Divide out the 5, and x is equal to negative 1. Remember, we're finding where the lines cross, so we need to write that as an ordered pair. So my answer to this problem is negative 1 comma negative 1. That's where these lines cross. All right. I almost asked if there's any questions, but there's no one here. It's just myself. So I've solved the system by multiplying one equation. Now I'm going to solve the system by multiplying both equations. So here we go. So the second problem, notice that 2 doesn't turn into 3 and 3 doesn't turn into 2 by multiplying by a nice number. 5 doesn't turn into -4, 4 doesn't turn into 5. So in this instance, I'm going to multiply both equations. The simple answer, the answer that the simple choice of numbers that you can use are going to be numbers from the other equation, right? So I'm going to multiply it, and I'm going to pick the numbers with the x because these numbers are smaller. So I'm going to multiply everyone in the top equation by 3 and everyone in the bottom equation by 2. So everyone up here gets a 3, you get a 3, you get a 3, and you get a 3. I'm like Oprah. Everybody gets something, right? So now we have 6x plus 15y, and that's equal to -30. I'm going to multiply now my second equation by 2, 2, 2, and 2. So now this is going to become 6x minus 8y is equal to, again, -30. Now, from the last lesson I gave, if I add these together, the x's don't cancel. And we saw that that's a real easy fix where we can just change all the signs of one of the equations. So I would like to change the sign of the bottom equation because now I'm going to make that positive and that's easy to deal with. And so let's see. So you become a negative, you become a positive, and now you become a positive. So the x's cancel. I'm left with 23y, and that's equal to 0. When equations equal 0, that just makes your life so much easier now. So now I divide both sides by 23, and y is equal to 0. So just like before, I pick either equation. I like the top equation. Numbers are a little bit smaller. So I get 2x plus 5. I'm going to plug in my 0 for my y, and that's equal to -10. That goes away. 2x equals to -10. Divide out the 2, and my x is equal to -5. So the point where my lines cross is -5, comma 0. Now, in both of these problems, the x is canceled. And maybe the y's cancel, and then you're left with the x, and you use the x to find the y. But again, I don't think that this is something that's too difficult for you guys. Again, this is something that we saw before, but this is just a good review lesson. Again, I hope everyone's doing all right out there. Please do the work. Let's take attendance for today. Have a good weekend, everybody. Let's just do what we need to do. We got a couple more weeks left, and we are graduating. So let's just do everything we've got to do. Have a good day, everybody.